record. All right, so let us move on. I'll share the recording with the persons who aren't here. A quadrilateral with one pair of side is, so this is a quadrilateral has four. We need to establish that the quadrilateral has four sides. Yeah, we have different types of quadrilaterals. That has to be established also. So this is a quadrilateral. A quadrilateral has a pair of, this quadrilateral has a pair of parallel sides. So these two sides are parallel. These two sides are parallel. Yeah. So trapezium, this can be a square, it can be a rhombus, it can be a rectangle. Because a square has all four sides equal. A rhombus has opposite sides and angles equal. All right, so it must be a trapezium. A trapezium has two parallel sides, all four sides and angles are unequal. So it has to be trapezium, all right? That's a trapezium. On to 22. Which of the following diagram shows triangles of equal area between parallel lines? And again, there's a rule here which we mentioned earlier on. The rule states that any triangle, so we have a triangle here, MON, M and O. Any triangle that is formed within the same altitude and share the same base has equal area. So look at this. So we have a line here, parallel line here. Let me draw this better. Now, any triangle that is formed, this is one triangle, yeah? Any triangle that is formed where they share the same base, that shares the same base is equal in area. Same base and same altitude is equal in area. Once they're within the same, this is the altitude or the height. Once the base is the same and the altitude is the same, the area is definitely the same. All right? So that area would be the same as here. All right? So that is that. Any question there? So which of these share the same base and is within the same altitude? Which of these? This comes closest. Well,
A, sir.
Definitely is A. A is the answer. Yeah, A is the answer. All right. A is definitely the answer. All right. This one, you'd have to be familiar with orthographic views, you know. I'm not quite sure if you guys did orthographic views, you know, but for this, using orthographic projection for the diagram above, which view G, with view G as the front, the end view H will be, so if here is the front, if G is the front, here would be the end elevation. Will be end elevation. Here will be the end elevation. So front, left end elevation, right elevation. E would be the plan. All right. So the end will look. This is pretty much what we would see looking from the end. So the end will look something like this. This would be the shape for our end here. And this will be the shape for our end. And if you're looking from here, we would also see this.
Sir, the answer A?
A, yes. Answer will be A. So once you move this, yeah, answer is A. (24) Which of the following diagrams best represent an external and an internal tangent? And which of these? So this is an external tangent. External tangent is something like this. Internal tangent can run like this or that. Once you touch on the inside, it's an internal. So it could be either this. It's an external meaning it goes touch on the outside. Internal means that it touches on the inside. So which best represents external and internal tangent? B, one external, one internal. So it would be B in this case. Which of the following diagram shows the proper method of bisecting an angle? Bisecting an angle. So here we have a line being drawn here, and we draw a line from this point where the line touch here. So first we draw an arc, right? Or to bisect an angle, this is the angle. We first draw an arc, random length, random radius. Then we place our compass at this point, square my next arc. Place here, square next arc. At the point where both arcs meet is their bisector. And this best represents that, A. Right? Any question, guys?
What was the answer, sir?
A. Again, guys, I'm gonna implore you to go through and watch those videos, because once you watch those videos, you'll be able to do all of these. All right? No.
Sir.
Yeah?
Sir, you don't have any notes you can give me?
Son, you don't need notes for this. You just need to watch a video. All the notes are there. The notes are in the book. You don't need notes for this. You just need to watch a video. You watch a video, all the notes are there. The notes are on the videos also. That's what I needed.
Yeah, that video on the YouTube channel.
So you just need to watch the traditional. Those will be the traditional drawings. It covers everything. Everything. Most of everything pretty much you say it covers. Just take some time and go through and watch those videos. That's all you need to practice from. You know, sit down in the back, watch the videos, and you're good to go. As I've said, it covered pretty much all of this section. All right. If a car picks up a tack on the circumference of one of its tires, then the path traced by the tack as the car is driven is called what? So this is it. This is the tire. And the car pickup attack right here. The car picks up attack right here. Picks up attack here. Picks up attack here. Yeah. And this part is rotated as the tire move along this part. As the tire move along this part, this also moves also. So which pattern is created here? This is on the channel also. We did this in class. The part created here is a cycloid. Cycloid. Again, go to watch those videos, guys. It's a cycloid. In the diagram, the ratio of the area of E, F, G, and H to that of E, G, I, and J is ratio here. All right. So what is this? Is this half? Is this 3/4? Is this 1-to-1? What is it? A simple way to solve this is to draw an external line here. Yeah. So so we have 1, 2, 3, 4 halves. 1, 2, 3, 4 halves. So here, for here. Well, yeah, so that would be half. So we have 1 for here, we have a different color. Again, these are things that are right there. So here we have a square here. Here we have a bigger one. So here we have 1, 2 path. Here we have 1, 2, 3, 4 path. So 2 to 4 is the same as half. All right. So if you look at this, this is split into half. You look at this, this is split into 1, 2, 3, 4. Yeah. And the rule also states that the rule also states that once a square is formed on once the diagonal of a square is the length of one side of another square, it is half of the area. So the diagonal for this is half, the diagonal for this is length of one side of the largest square. The rule states that it is half area. All right, that's a given. All right, let's move on to the next page. Which of the following diagram correctly shows the bisector of a line? And this is that most basic. Which of these show the bisector? Is it A? This is the bisector. A bisector is a B. A bisector is a line that cuts or divides a line into two equal parts. Which of the following represents the size of an angle X?
I just a while ago, sir, they are break up.
This is the bisector right here. This is the bisector of the line. This
Oh, all right, sir.
What is the X right here? What's the value for X right here, gentlemen? Which of these should the value for X? 30. Yeah, 30. Which of the following diagrams represents the drawing of a tangent to a circle at a point on the circumference? This one, A, is the correct way to draw a tangent. If the length of a line in a drawing is 25 millimeters and the scale ratio is 1 to 10, then the actual length is, so if the length of a line on a drawing is 25, and the scale ratio is 1 to 10. Then 1 to 10 means that that is divided by 1 to 10 is the same as 1 over 10 times 25 divided by 10. We move with decimal place 1, we get 2.5. So this is the correct answer. Man, I'm tired. The rectilinear accuracy of the figures can be tested by measuring the diagonal. Rectilinear means that it's a rectangular, mean that it's rectangular. All right. So in other words, they're asking you if all the 4 angles are 90 degrees. A rectilinear figure has all its angle at 90 degrees. And the only way to test that is to measure diagonally from here, measure from here to that point, and here to that point. If from this distance must be the same as this distance for it to be equal. Yeah, so we must measure the diagonals for this. Which of the following is the eccentricity of FP to PQ? It's 1 to 1, because here FP to PQ, here this is equal to that, so it's 1 to 1. Which of the following development shows a cylinder which is cut obliquely at both ends? And this one right here. Yeah, this one. This would be a cone. This is something else. So this would be the one. So what you have here is this being cut at both ends. Yeah, so it's being cut here and being cut there. So when you unfold this, it creates a pattern like this. So it's D. Which of the following instruments is used when drawing an irregular curve on a surface? French curve. That's B, French curve. Refer to the following diagram. The diagram shows the development of a truncated, this is a cylinder. Once it's shaped like this, it's a cylinder. So this is a truncated cylinder. The perpendicular distance between lines PQ and RS of a trapezium. So trapezium, remember, trapezium looks something like this. trapezium. All right. Right. So remember, a trapezium has two parallel sides, something like this. Or something like this. Right. So the two parallel, the perpendicular distance between line PQ. So here is PQ and RS of a trapezium. PQRS is 3.5 millimeters. So here is 3.5 millimeters. From here to here. Here to there is 3.5 millimeters. 3.5. PQ, RS, which of the following line would be parallel? RS, PQ is one, and RS is one also, right? So the answer would be RS, and QP. So it'll be RS and QP. Right? The lines marked X on the diagram are symbols which indicate A, the axis of symmetry parts, the axis of symmetrical parts, that the edges are to be measured, that sections to be removed, the continuation of the object. This represents that the object has been broken or a section has been missing or there is continuation. All right? This means continuation, meaning it extends some distance. So this is that.
Yeah, me thought one question a while ago.
Huh?
Scroll up.
I missed one.
You never do that. Oh, that one there.
This?
Irregular curve.
Yes, ma'am, we did it already.
Oh.
French curve.
French curve. All right, sir.
35 is French curve. All right. Triangle ABC is drawn within a semicircle of diameter 100 millimeters. AB is equal to 80 millimeters. What is the length of BC? All right. So here, if AB 100, BC, and AB. What is the length of BC? What's this length right here? All right. Look at this length and look at that. Well, it could not be this because this is clear. It could not be. It could not be that. 36. It is more than half, so it could not be 36. 50 or 60. 60 would be I would say this is, looking at here, I would say this is 60. I would do 60. Of course, you could match it out. You could also match it out. So I would say this is 60. Yeah, this is 60. Okay, let's move on to 41. Which is the value of angle beta? 60. Angle beta is 60. As in isometric, the basic here is 30. Here is 90. So the angle here is naturally 60. Any question? Pause it.
I just know, man.
All right. When a draftsman is drawing a true horizontal line, the pencil point should be guided by T square. That's B. Which of the following best describes a quadrilateral? D. A plane figure bounded by 4 straight lines and the internal angles add up to 360. Which of the following diagrams shows the correct division of a line geometrically into 2 parts in the ratio of 2 to 3? Of course, this is B. 2 parts, 2 and 3 parts. Which of the following methods of drawing an ellipse involves constructing a rectangle? This is the intersecting lines method. Intersecting lines method. A development of an object is a drawing showing the unfolding of its surface. Which of the following diagram shows the correct procedure for drawing a perpendicular, drawing a perpendicular at the end of a line? B. In technical drawing, the phrase curves meeting each other tangentially means that the curves will meet smoothly. Yes, it means that they will meet smoothly. A. In the diagram, a crank QR rotates about a fixed center R. A rod PQ is pinned to the crank at Q and freely slides in a guided at P. The locus trace by point S for 1 revolution of QR is an ellipse. Is an ellipse. So when this moves along here and this goes around, so this from here, this comes here. We have 1 here. But it's an ellipse. Here we'll form a path like this. It's an ellipse, which is B. The drawing above is to be reproduced by 3rd angle projection. On which of the following views can the distance x be seen? X would be seen here. Here is one face. So, and here is the front elevation. Hold on there. No. On which of the following views can the distance x be measured? You can measure x. Here is the end elevation. Here is end elevation. Here is the top. So this distance would be visible on on the plan and also on the end elevation. So this is plan and end elevation. So it's 1 and 2, 1 and 2 only, 1 and 2, 1 and 2 only. That is A. A netball court has a length of 30 meter. A line represents this distance measures 3 centimeter. To what scale is the line drawn? So we will need to equate these. So 3 centimeter, when you multiply this by 100, we get 3,000 because 100 centimeter equals to a meter. So this is, so 3 to 3,000 would work out to 1 to 1,000. So the ratio would be 1 to 1,000. Which of the following is a view of a right square pyramid? This shape is a cone. This shape is a prism. This is the correct one. This would have been more than 4 sides based on the shape. So this would be the correct one. This is a square pyramid. A pyramid has all the sides meeting at a point. Which of the following views would show an object as if it were cut across, exposed inside detail? That would be a sectional view. Sectional view, yeah. So you cut the building and you show what's on the inside. When designing a new product, which type of drawing is usually made first? Sketches. You first need to sketch. Which of the following layout represents the correct orthographic view of a shaped block? Well, so for this block seems to look something like this. Here is the front. The front would shape like this. Front would look like this. The plan would look something like that. We have this edge coming down here. And the end, when viewed from here, would look something like this. So anyone that look like this is the right one. No, not that. Not that. Oh, this is the one. This is it. We have a minute and a half to go. Once this ends, we're gonna call it a day, all right? I'm gonna convert these very long videos and try upload them. A circle is drawn inside a polygon. If that circle touches all the sides of the polygon, it is known as an inscribed circle. An inscribed circle. So you have inscribe, ascribe, and you have circumscribe. All right? Inscribe, let's a minute to go, I don't want, it's an inscribed circle. A student falls and hits his head hard against the edge of a technical drawing table. He is most likely to suffer from a concussion, right? The diagram shows the construction of a regular hexagon giving the length of one side, which is A. Which of the following represents the correct form of the first angle projection? This This C. Definitely C. All right. It's definitely C. So guys, you have a minute to go. Less than a minute to go. Well, seconds to go. It was nice being here. I